Who thinks the rectangle is the larger shape? Raise your hands. Okay, why? And all the hands go down. Dylan, why?
Because I think if you put the circle on top of the rectangle,
Okay.
there's more open space than.
So if you put the circle on top of the rectangle, there's more open space?
There's more space in the rectangle.
There's more space in the rectangle. Did you actually physically copy it over?
I mean, I was going to, and then I
Did you guys draw a circle around the circle in Notability? And then maybe put it over it?
Yeah.
Maybe try that, okay? All right, any other ideas why this rectangle would be bigger? Mario?
Why would you say they're equal?
You want to say that they're equal? Okay, yep. They're equal as well, okay? Anyone else?
I think the circle.
Who thinks the circle's bigger? Raise your hands. Why? John, why?
Because it just looks bigger. Look at it.
It just looks bigger. Just look at it. Okay, that's a great argument. JL, yes, you can. Anyone have a better argument? Yeah.
Dang, what is there to think about, bro? Look at it. Circle goes over the rectangle.
Are you saying because it's rounded, right? It takes up more space? Okay, that's one way to look at it. Yeah. They are not equal. One is actually bigger than the other one.
It's the circle.
Sophia, what were you going to say?
I was going to say the triangle, the square, if you look at it, it's made of two triangles. And each triangle is 180 degrees, which is 360.
Okay.
And the circle is made out of 160 degrees.
Okay. So you're saying that they're equal?
Yeah.
In degrees, they are equal. But remember, degrees is not area. So if I drew another rectangle, do you agree that this rectangle also has 360 degrees inside of it? Is that the same size as this circle? See my point? Okay. What else? Any other arguments? Alexis? Because what? It's enclosed?
Yeah.
I would say both of them are enclosed, right? Because there's no, this one's not an open shape. The circle's bigger, but why? Just because it looks bigger?
Yes. Yes.
Okay, if you said that the circle is bigger, you are correct.
Oh!
Now, let's see why. And I need you to copy this down because I don't like our arguments for why the circle is bigger. I need you on the circle to draw a radius. So find somewhere close to the center and draw a radius. What's a radius, people?
3.
Half the diameter. It starts in the center and goes where?
To the side.
To the edge, okay? Then I need you use the lasso tool in Notability to copy the said radius and put it next to the rectangle. Oh, goodness.
Oh.
That's just width, not height.
What?
In height, it's longer too, bro. Look.
Hold on.
In height.
Hold on. Let's do it again. Approximately,
Duplicate it again.
how many radii is that bottom side of the rectangle? So let's represent it by 2 times what? R. I like it. Do the same thing with that side, this side, on the right-hand side. Let's do the same thing.
Part of the white's stretching out.
What do you mean part of the white is stretching out?
Like the out, the longest part, literally.
I don't know what you mean, Scott. Can you explain?
It's you see the white, it's further away from the blue.
I did Mr. Bro.
The white is further away from the blue.
No, it's more out than the blue.
Oh, because it came over just a little bit? Yeah, but I would say it doesn't finish right over here. Do you know what I mean? So maybe if we shifted it over, it would be exactly 2R. It's an approximation. It doesn't have to be perfect, okay? But you do bring up a good point. So is this equal to 1 radius? Or how many? It's definitely less than 2. Do you guys agree? Because when we stack them on top of each other, right? Oops. What up? What up? What would you say it is? About how much? It's at least one radius, right? But it's more than one. Could we approximate it by like 1.5? So 1.5 radiuses, right? Approximately. Doesn't have to be perfect, right? About 1.5. Okay. What's the area formula for a rectangle? Base times height. And what's the area for a circle? Pi r to the second power. Okay? All right. But in our rectangle, we want our base and our height to be represented by the figures that we just had. So, or what we just came up with in terms of r. So we're going to say area equals, what's the base here? What's the base here for the rectangle? 2r, right? And what's the height? 1.5 r. Okay? What if I multiplied these together? 2r and 1.5 r. What would I get? 3r squared. Okay. Does this area now look similar to this area? Which one's bigger? The circle? Why, Danny? What was that, Danny? Very good. Remember what pi is, guys. Pi is just 3.14 approximated times r squared. So this circle has to be bigger, right? Because the area of our rectangle only got us to 3 times the radius squared. Yeah, Dylan? For pi? Where pi comes from? So if we're determining which one's going to be bigger, the circle had to be bigger because it's 3.14. Now, are they pretty much the same? Is 3 almost the same as 3.14? I would say yes, and they are very similar, okay, in terms of their size. But the circle is slightly larger because it's 3.14 versus 3r squared. Yeah, Val? Yes, you may, okay? All right, so just a fun little activity to do for the warm-up. Yeah, one. Why is pi what? Why does pi exist? So pi is related to anything that's circular, right? So when we're talking about the area of a circle or the circumference of a circle, you have to use pi because it allows you to get that curve, right, when you're talking about length or distance, okay? I don't know its actual, why it's the number that it is, okay? It's just related to anything circular, okay? And you'll notice that pi exists when we talk about, in Algebra 2, when you develop, polar coordinates, which are coordinates of, in a circular sense, okay? You'll also be dealing with pi, okay? Are there any other questions in regards to this warm-up? These are good questions. Okay, guys, today's lesson is probably one of the lessons that has the least to do with math that you'll see in a long time, okay? It's all about vocab. So you need to make sure if you want to make a Quizlet for this stuff, that's a really good idea, but it's a lot of vocab, okay? The first thing that we're going to talk about in terms of vocab is what a polyhedra is versus something that's not a polyhedra, okay? There are 2 shapes on the left, and those 2 shapes are a prism and a pyramid, and both of those are considered polyhedra. The shapes on the right, which are a cylinder, a cone, and a sphere, are not polyhedra. I would like you, to the best of your abilities, to write what you think the definition of a polyhedra is based on these shapes. Write it down in the space below right now, and we will compare your answers in a moment. So again, you don't know what a polyhedra is right now, but based on these examples, what do you think is the difference between polyhedra figures and not polyhedra figures? Okay, what do you think the difference is between polyhedra figures and non-polyhedra figures? Yeah, Dougie.
Polyhedras are shapes made of straight lines, while non-polyhedras are shapes made of curved lines.
Excellent. Straight lines. Curves or curved lines. What else? Yeah.
Polyhedra
Very good. Polygons. What is a polygon, guys? Yeah, the shape with sides. And not polygons. Anything else? Hannah? Okay, yes. You said the base of a polyhedra is a quadrilateral. We are going to see some examples where it's not a quadrilateral, but the cool part is that they do have bases. So these have bases. Some of these have bases, right? Like a cylinder and a cone. But does a sphere have a base? So they don't necessarily have, not all have bases. Anything else? Yeah, Gio? Polyhedras have edges. Very good. Straight edges, to be specific, right? Anything else? Okay, these were really good, okay? The formal definition of a polyhedron, okay, is it's a solid bounded by polygons. And remember, polygons are sides with, or shapes with sides, okay? And those are what we call our faces. So anytime you see a polygon on a polyhedron, it is a face of the polyhedron, okay? The edges are the segments that are formed by the intersection of two faces. So where two faces meet up, that line segment is considered the edge. A vertex is the intersection of three or more edges. And the plural form of polyhedra is a polyhedron. All right, I would like us to identify all of the vertexes in this figure below and count all of them up. So using the dot that they did, the large red dot, identify where every single time there's a vertex and count them up. How many vertices are there in this figure? 8. Very good. So put a V and put the number 8. Next, I would like us to identify the number of faces that this has, okay? The number of faces is the number of, sides of the figure, okay? Yeah. There's 6 faces, okay? There's that side on the top in red. There's the side on the bottom in blue. And then there's the 4 blue sides all along the edges of your figure. There's a face over here, a face in the back, a face on the left, and a face in the front. Plus the 2 on top and bottom, that's 6 in total. What questions do we have about the vertices or the faces so far? We're good? Okay. What about the number of edges? How many edges does this figure have? Danny? 8. Very good. You can draw them out. 1, 2, 3, 4, 5, 6, 7, 8. Uh-oh. There's more than 8 edges. 9, 10, 11. There's 12. Okay? Don't forget, even those dotted lines in the back of your figure, they're dotted because visually, if you were looking at this and it was a solid figure, you wouldn't see those, okay? So they're dotted for a reason, but they still count as edges, okay? There are 12 edges here. Are there any questions on vertices, faces, or edges? Cute. Okay, move on. So, again, this is the exact same slide as before, okay, versus the types of solids. We have polyhedra or not polyhedra, okay? They're the exact same figures, okay, just again for you guys to look at them. Let's talk about what a prism is. Yes?
Is there ever a name for the non-polyhedras, or do we just call them non-polyhedras?
We just call them non-polyhedras, okay? Yes?
Are there only 2 types of polyhedras?
There are only 2 types of polyhedras, and that's what I'm going to get into here, okay? The first type of polyhedra is a prism, okay? A prism, it uses the name of the shape of its base, and there will be 2 bases in a prism so that you name it, okay? This is a pentagonal prism, Why do you think it's called a pentagonal prism? The bases are pentagons. Very good. The bases are pentagons. Guys, if it helps, outline the base here. This is a base. And do you see the base at the bottom of the figure as well? They're both prisms. Now, the lateral faces will always be parallelograms, okay? The lateral faces will always be parallelograms. But the bases are what define what kind of prism it is, okay? You'll notice each of these parallelograms, okay, are actually rectangles, okay, along the edges of your prism. Danny, what's up? Okay. The altitude or the height of the prism is the perpendicular distance between its two bases. We're going to fill that in, guys, okay? So I want you to draw a line from the very bottom of your figure up to the top base and make sure that line is perpendicular with the bottom base, okay? It's actually perpendicular to both bases. This is considered the height or the altitude of this prism. From one base to the top base. Bryson, you good? Okay. Now, your bases in a prism, okay, they will be in parallel planes, okay? And they will be congruent to one another. Yeah, what's up?
So if like the bases were like rectangles, it'd be like a rectangular prism?
Correct, if the bases were rectangles. Would you guys like me to draw a rectangular prism just so we see another one? Okay, so draw two rectangles that are the exact same. Draw them one on top of the other. And then you're going to draw lines connecting the edges to one another. And we should have made this one dotted behind, okay? The two bases, both of the bases are rectangles, okay? So it is a rectangular prism. Does that make sense, Danny? Okay. All right, and the second type of polyhedra is a pyramid, okay? A pyramid is different than a prism. Does a pyramid, look at the pyramid down below, how many bases does it have? One. The base, okay, all of the lateral edges, okay, meet up at a point at the top, okay? Think about like the pyramids in Egypt, right? Do you know how like the pyramids, they like get smaller as they go up? They meet at a point at the top, okay? That's a pyramid. So it only has one base, which is ground level, and then it meets at a top, okay? That's the difference between a pyramid and a base. It only has, or a pyramid and a prism. The number of bases is one for a pyramid, okay? The altitude then, guys, is going to be, and we're going to draw it in, a line drawn from the vertex down to the base, and it must be perpendicular to the base. What shape would you say this base is? Yeah.
It's a quadrilateral.
Okay.
Can I check my iPad?
Sure. It kind of looks like a square, right? If we didn't know that all four of those sides were the same length, what shape would you say it approximately is? More of a rectangle, right? So we'll call it a rectangular. What? Was it a prism or a pyramid? Pyramid. We'll call it a rectangular pyramid. What's up?
What if it was like a square? What would we call this side?
It would have to have congruence marks on them, Danny. So you would have to know that each of those sides were the same length.
Yeah, but like what would it be called then? Would it be just called a prism?
Oh, a square pyramid. Okay? All right. Next, in these three examples, we have to tell whether the solid is a polyhedron, and if it is, we're going to name the polyhedron, okay? Number one, polyhedron or nah? Yes, polyhedron. Why? Because what? Because what? They're all straight lines, okay? There's no curve to it. Pyramid or prism? Why is it a pyramid? It has what? One base. And then we have to define what kind of pyramid that is. What's the shape of its base? Christian? Very good. It's a square pyramid. The second one, polyhedron or not? No. Why? Good. This is not a polyhedron. Okay? It has a curved edge. Okay? It has a curved edge, not a polyhedron. And we do not classify yet not polyhedrons, okay? If it's not a polyhedron, we don't have a name for it yet. Number 3, polyhedron. Yes, it's a polyhedron. Let's be as specific as possible. Prism or a pyramid? Prism. What is the shape of the base? Not a rectangle. It's a triangle. So we're going to put triangular. But let's be more specific. It's not just a triangle. What kind of triangle is it? It's a right triangle. How do you know it's a right triangle? Has a 90-degree mark. So this is a right triangular prism. Danny.
So is the base the one that always has the right angle?
No.
How do you tell?
How do you tell if it's the base? There should be exactly 2 of them. Do you see how there's 2 bases and they're the exact same size?
And
There's 3 rectangles and not all the rectangles are the same size. Do you agree? 2 bases, okay? And Danny, do you see how all the rectangles are not the same size? This rectangle up here is clearly bigger than this rectangle over here on the left. Remember, your bases need to be congruent to one another, okay? All right, questions on this page? What questions we got? Are we okay? Yay. Okay, Euler's theorem, okay? Euler's theorem says that the number of faces, vertices, and edges of a polyhedron, guys, it has to be a polyhedron, are related by the formula F plus V equals E plus 2. F plus V equals E plus 2. The number of faces plus the number of vertices equals the number of edges plus 2. You good there, German? Yeah? Yeah. Okay. All right. So let's apply Euler's theorem, okay? This is helpful because when we're calculating faces, edges, and vertices, okay, we want to be able to identify if we have the right number or not, okay? So we've done these examples before in terms of identifying them, okay? But now we have to figure out the number of edges, faces, and vertices, and we're going to see if they satisfy Euler's theorem. Let's take a look at A. Let's start with the number of vertices. How many vertices does this guy have? 1, 2, 3, 4, 5. So there's 5 vertices. How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 edges. It helps guys to count and trace it out as you go, okay? And then lastly, how many faces are there? Oops, that's not a good color to write with. There's not just one face. There's the bottom face. There's the face on the right, the face behind, the face on the left, and the face in front. How many is that? There's 5 faces. Now, to check to see that you got all of them right, you're going to add the vertices plus the faces, and that should equal the edges plus 2. What was the number of vertices? What was the number of faces? What was the number of edges? What's 5 plus 5? What's 8 plus 2? As long as these match, you nailed it, okay? So 10 equals 10, that's Gucci, we're done. So this is true for all polyhedra, okay? This is just, Hayden, we were plugging it into Euler's formula to make sure that we got the right number of vertices, edges, and faces. Yeah, Amanda?
Is this and what we just learned from circle?
Okay, so number 2, letter B was not a polyhedra, okay? So we're going to not do this one because Euler's theorem only applies to polyhedra, okay? Letter C, how many vertices are in letter C? 2, 3, 4, 5. I counted 6. Did you guys get 6? Okay. How many edges are in letter C? 1, 2, 3, 4, 5, 6, 7, 8, 9. I counted 9. And then how many faces are there in letter C? 1 here, 2, 3, 4, 5. Are there 5? So I add V plus F should be equal to edges plus 2. The number of vertices was what? 6. The number of faces was? Then equals the number of edges. 9 plus 2, we got 11 equals 11. We're Gucci. Yeah. Yeah, so if, let's say you got 12 equals 11, right? And you agree that we said that this was a polyhedra? One of your numbers is off. So go back and recount your vertices and recount your edges and recount your faces. Because maybe you missed a face. Usually it's the faces. That's what tends to get students, okay? But something's off. And then you know, okay, let me go back. So this formula, guys, is great for like, if I asked you how many faces, edges, and vertices does this figure have, you can use Euler's theorem to check whether you got them all 3 of them right, okay? What questions do we have on this example? Okay, moving on. So we're lastly going to talk about cross sections, okay? So imagine a 3-dimensional figure, okay? Imagine that all 3-dimensional figures are like a block of cheese, right? And you're cutting that block of cheese with a knife. When you hold that block of cheese up, you're gonna see a shape on the face of the block of cheese where you cut it, right? So depending on where you cut this figure, you're gonna get different shapes. And then these examples, it's gonna be whatever the purple region is, that's gonna be considered our cross section. So our knife, right? I'm gonna try my best to draw a knife. That was pretty bad. But it's cutting, right, your figure, however the plane cuts your figure. And then you're looking at what shape gets created, what 2-dimensional shape gets created based on that cross section. What would be the cross section for this figure? Very good, it's a triangle. Okay? And by definition, guys, a cross section, it's the intersection of a plane that's slicing through a 3-dimensional solid. All right, let's do some examples where we're identifying what sort of shape is the cross section. Take a look at letter A. What shape would you say the cross section of letter A is? It's a rectangle, very good. You can't say it's a square because do we know that all the sides are congruent? No. You could also say, let's say you're like, I don't know if that looks like a rectangle to me. What else could you have called it? Quadrilateral, or more specifically, you definitely know it's a parallelogram, right? Okay. Letter B. Danny? This one's for sure a rectangle. Letter C. What's that? Not a rhombus, yeah? Trapezoid. This is a trapezoid. Okay. Remember, a trapezoid has one pair of parallel sides and the other two are the legs. Letter D. This one's confusing because it's a cube, but this cross section, it's not a kite. It's a triangle. Okay. Remember, Diana, it's only the purple section. Okay? And the purple section forms a triangle here. All right. Letter E. circle. Okay? Or you can say oval if you're like, I don't see a circle there. Okay? You can say oval as well. Yeah.
Is a cone considered a polyhedron?
No, it's not. Why not? It's rounded, right? Remember, a circle is not a polygon. Okay? Polygons have sides.
Our cross section is gonna be like, are they both?
Polyhedron. So cross sections can intersect both polyhedrons or non-polyhedrons. Okay. First one. Okay.
Yo, like, why can't we say that it's a square, like, it's a cube, but like.
Yeah, but it would have to physically show you, Gio, that all four of those sides are the same length for you to call it a square. Okay. All right. Let's do our last three. Number 4. Yeah.
I have a question on the first one.
All right. Number 4. Yeah. Very good. It's a pentagon. And you'll notice in number 4, the cross section is parallel to the bases, right? So whatever shape your base is in this case, that's going to be the shape of the cross section. It's when that cross section gets diagonaled and is not parallel to the base, that's where you get those funky looking cross sections, okay? Number 5, that one's a hexagon. Very good. And last but not least, number 6, this is a circle. Or you can say oval, okay? Yes. Yes, it would be. Hexagonal pyramid. All right, guys, that's it. So turn these in, and then you guys can get started on your big ideas.